uh, nowadays you all are studied online, so it is difficult to do the practical or experiment physically. So we are using the virtual lab, okay, for doing the experiment. So how we can do the experiment in virtual lab? So generally the lab is is designed by the IIT Bombay. So just you can do by yourself also the same thing. Just we have to write the virtual, simply you can say digital electronics virtual lab IIT Bombay. You can enter there. In the very first step, we have digital electronics virtual lab by IIT Bombay. You can click on that. So this screen will be open. So in which we have introduction, a list of experiment, which target of audience they are proposed to, and a course alignment. So we do not have to focus on introduction and target audience and a course alignment. We are going to the list of experiment. So these are the list of experiment which we perform by using a virtual lab. So the first one is the verification and interpretation of truth tables of NAND gate, OR gate, NOT gate, NAND gate, NOR, exclusive OR and exclusive NOR. So generally we have these are the basic gates and or NOT, NAND NOR, exclusive OR and exclusive NOR. So we have to verify its truth table, and we have to design that gate by using a diodes and transistor. Okay, so you can do the experiment by yourself also. So today we have to perform a first experiment, which is verification of interpretation of truth tables for all the logic gates. The here we have the list of experiment. In second experiment we have half headers and full headers, and in third experiment we have again a subtractors. So these are the list of experiments. So we have 12 experiments, and we are performing these 12 experiments by the virtual lab. So once you click on the first experiment, verification and interpretation of truth tables, it will open the link. Okay, and this all things are in the come under the or initiative by the MHRD, so which is the Ministry of Human Resources Development by the Government of India. So you can perform the experiment by yourself also. So this is our first experiment. So you can see in tab we have aim. All the things are given in that aim, the theory, the pre-test, what is the procedure, the simulation, a post-test, and the references. Okay. So what is the aim of that experiment? So it is easily written that we have to verify and interpret the logic and the truth table of all the basic gates by using RTL. What is RTL? It is a resistor transistor logic. DTL again it is a diode transistor logic. TTL again it is a transistor logic. And we can also perform its simulation and verify the truth table of all the basic gates, either it is AND or NOT, NAND NOR, exclusive OR and exclusive NOR. Okay. So this is the aim of our today's experiment. So come to the theory. So this is the theory portion of the logic gates. So you see they are giving the introduction also. So what is the logic gate? Logic gates are the basic building blocks. Logic gates are the basic building blocks. of any digital system. Suppose if you want to make a adder, or if you want to make a subtractor, if you want to make a multiplexer or demultiplexer, encoder, decoders, these all are the combinational circuits. Then you have to design a flip flop, which is a sequential circuit. Okay. uh, so all that thing, wait a minute. So all that things are made by the logic gates only. Either you can use AND gate, OR gate, NOT, NAND, NOR, exclusive OR, or exclusive NOR. So all that things are made by the logic gates only. So this is the basic building block, or you can say in memory also. Some of the time we are using a gates in A to D and D to A converter. Again, we are using a basic gates. So these are the basic concept of the digital electronics, or you can say the basic building block diagram of digital systems. So again, how we can make a digital or logic gates? Again, that logic gates are made by the electronic circuits we have. So as an electronic circuit, we can use diode and transistors. Okay. So generally, the logic gates having more than one input, but we have only one output in a logic gate. So you have one input logic gate, you have two input logic gates, you have three input, four input logic gates, but as output we have only one output. So as you see in the screen, we have to study these seven basic logic gates, which is AND gate, OR gate, NOT gate, NAND gate, NOR gate, exclusive OR, and exclusive NOR. So we have to check its symbol, we have to check what is the equation for that, and we have to check what is the truth table of that particular gate. Now, what is AND gate? Again, this is the thing which I think you already studied in the subject basic electronics. So this is the revision of that. Now, what is AND gate? So simply, AND gate is an electronic circuit gives the high output only if all its inputs are high. So suppose we have two input AND gate. So when it will give you a one as a output, so if both the input of the AND gate is high or a one, then and then it will give you the output one, or you can say high. Otherwise, it gives you the output zero. And its equation is A dot B. So it is a multiplication of two input AB. Suppose we have two inputs A and B, and if we multiply that two input, then this is the expression for the AND gate. You can see in your screen we have the simple symbol of AND gate, which is uh, you can easily see in the screen. The equation of AND gate is A into B. So once suppose we have two inputs, so how many possibilities we have? So for the particular input, we have to 2 raised to n possibilities. Suppose if you have only one input, so how many possibilities we have? 2 raised to 1 is equal to 2. So we have two input possibilities. Either it will be 0 or it will be 1. Suppose you have two inputs. How many possibilities we have? 2 raised to n, when n indicates the number of input. N indicates the number of inputs. So we have 2 raised to 2. So we have four different possibilities of the input. Suppose if you have three inputs. So again, how many possibilities we have? 2 raised to n, but n is equal to 3. So 2 raised to 3. So we have 8 different possibilities. Okay. So these are the thing for particular input. So we have two inputs. So what is the possibility of that two input? Either it will be 0 0, or it will be 0 1, or it will be 1 0, or it will be 1 1. So the equation of AND gate is A into B. So you can simply calculate by your simple rules of multiplication. As we know, 0 into 0 0, 0 into 1 0, 1 into 0 0, and 1 into 1 1. So when the output of the AND gate will be high, when all the inputs of the AND gate will high, then and then output of the AND gate will be high. When all the inputs of the AND gate will be high, then and then the output of the AND gate is high. So So you can easily see the truth table of AND gate. Now AND gate can be constructed by the RTL logic. What is RTL? It is the resistor transistor logic. So simply as you already studied, diode is also work as a switch and transistor is also work as a switch. So here we are using a transistors and a diode as a switch. We are working a transistor and diode as a switch. Okay. So which transistor we are using? We are using two NPN transistors. Okay, we are using two NPN transistors. Again, as a concept, we have two types of transistor. One is the NPN, another one is the PNP. Transistor having the three terminals known as the emitter, base, and collector. And diode have a two terminals which having a name anode and cathode. Okay, so this is the uh, circuit of RTL from which we can implement the AND gate. So you can see we have two inputs A and B and we have one output B. Suppose you have both the A and B is 0. If both the A and B is 0, we are not getting any gate pulse. See, the input of the transistors are connected with a base. Input of we are connected with base. So as we are not giving anything in a base, so supply will not come to the transistor and transistor will be off. So if A and B is 0, all both the transistor is 0. So T1 and T2 0. It will not on. So what that means, our output will be 0. If you give the pulse to the A and you are not giving pulse to the B, so my A is 1 and B is 0. Suppose my A is 1 and B is 0, then my transistor T1 will be on, but again my transistor T2 will be off. So that's why my output will be 0. Suppose you are giving the input to the B T, at the transistor T2 and you are off the transistor T1. So again both the transistor T1 and T2 will be 0. Because we are giving the pulse to the base, but transistor does not get the plus VCC supply because it is connected with T1. So again T1 and T2 will be off. And the last one, suppose if you are give the pulses to the both the transistor, then my T1 and T2 will be on, and then my output will be 1. So this is the basic figure of AND gate made by the RTL, which is resistor transistor logic. So we have to focus on the truth table of the AND gate, which is 0 0 0, 0 1 0, 1 0 0, 1 1 1. So when all the inputs of the AND gate will be high, then and then the output of the AND gate will be high. So this is the basic rule, and the equation we have to know. The equation of AND gate is AB, or multiplication of two inputs. Same way we have OR gate. You can see the symbol of OR gate and the equation of OR gate is A plus B. So again we have two inputs. So when the output of the OR gate will be high, if any one input of the OR gate will be high, then output of the OR gate will be high. Again I am saying if any one input of the gate will be high, then the output will be high for the particular OR gate. So what is the truth table of OR gate? Suppose A and B 0 0. So both the input is low. So the output of the OR gate is low. Suppose 0 1. Now any one input will be 1. So we have one input as a 1. So output of the OR gate is 1. So 0 1 1. Again 1 0. So 1 0 1. And for 1 1. For 1 1 again it is 1. So this is the truth table of the OR gate. Again, OR gate you can realize by the TTL logic, which is transistor logic, or you can realize by a DRL logic, which is diode resistor logic. So generally, presently we are showing you the a diode resistor logic. So we have two inputs A and B. If both the input will be 0 0, so both the diode number 1, you can say connected with the A, and diode number 2, you can say connected with B. Both are not working because we are not giving any supply to the diode. Suppose we are giving A as a 1. So my diode 1 will be forward bias and it gives you the output. Okay. So any one diode will be 1, then we are getting the outputs 1. So if we are not getting any input, if we are not giving any input to the diode, so both the diode D1 and D2 becomes reverse bias. So both the diode will be reverse bias, so it will not work. And if you are giving a voltage to any one particular diode, then it will be work. It will be work, and it gives you the output 1. It gives you the output 1. Okay. So this is the circuit of OR gate to DRL logic. The next one is the NOT gate. Generally, NOT gate we have only a single input gate. Otherwise, all the other gates like AND gate, OR gate, NAND gate, NOR gate, exclusive OR and exclusive NOR, all are the particularly generally two input gates. But NOT gate we have only a single input NOT gate. We have only single input NOT gate. So NOT gate having only one input and one output. So you can say NOT gate as a reverse gate also. It is an invert gate. So NOT gate is an electronic circuit that produces an inverted version of its input. It produces inverted version of its input. So suppose if you are giving input 0, then it will be invert the input, so your output will be 1. Suppose your input will be 1, so it will invert your input and the output will be 0. So this is the case in a NOT gate. So you can see the truth table. We have only one input, so as a one input we have only two possibilities of input. Either it will be 0 or it will be 1. Either it will be 0 or it will be 1. So once you are giving input 0, it will give you the output 1, and once your input will be 1, your output will be 0. So again, you can realize a NOT gate with a single transistor only. So your output, suppose your input is A, then your output will be A bar. Your output will be A bar. Okay. So this is the circuit which is realize the NOT gate by using a transistor. So NOT gate can be realized through a transistor. So input we are connecting through the resistor to the transistor base. So when there is a no voltage present, so transistor will be off, and as the transistor off, the output will be comes, all the VCC supply comes to the A bar. So my input is 0 and my output is 1. But suppose your transistor is on, then all the supply is grounded. So your output will be 1, then your input will be, when your input will be 1, then your output will be 0. So this is the NOT gate. The next one is the NAND gate. So NAND gate is very easy compared to how we have to make the NAND gate. We have to put AND, and above the AND we have to connect a NOT gate at the output of AND gate. We have to connect a NOT gate at the output of AND gate, then it becomes NAND gate. So the equation of NAND gate is A dot B bar. What bar indicates? Bar indicates the invert. Bar indicates the invert. So again, this is a NOT AND gate, which is equal to AND gate followed by a NOT gate. So as what NOT gate does, it inverts the output, or you can say it inverts the input. So the NAND gate is the opposite of the AND gate, or the truth table of NAND gate is reverse to the AND gate. So for AND gate we have 0 0 0 0 0, sorry, 0 1 0 1 0 0 and 1 1 1. For AND gate, when both the input is 1, then and then output will be 1. For AND gate, both the input will be 1, then and then output will be 1. But for NAND gate, it is reverse for the AND gate. When both the inputs are high or both the inputs are 1, then and then output of the NAND gate is 0. Then and then output of the NAND gate is 0. So all the possibilities are giving the output 1. So my output is 0 0 1, again 0 1 also 1, 1 0 also 1, and 1 1 0. So again we can implement a NAND gate with RTL logic only, but now the connection will be reverse. The output first we are connecting for the AND gate below the T2, but now for no NAND gate we are connecting output above a T1. You can see the difference between two circuits. Now above a T1 we are connecting. So this is the circuit of a NAND gate. So if both the inputs are 1, then and then my T1 and T2 will be 1. And as my T1 and T2 will be 1, so my T1 and T2 is on. And as my T1 and T2 is on, so my supply VCC is grounded. So my output is 0. So only one possibilities we have when my output is 0, when my T1 and T2 will be on, or T1 and T2, the input of T1 and T2 is 1. Otherwise, my output is always 1. Otherwise, my output is always 1. So this is the case for the, or you can say the circuit of the NAND gate. Next one is NOR gate. Again, it is the same thing as we have in NAND gate. Again, this is a NOT AND gate, NOT OR gate, as we have a NAND as a NOT AND gate. So we have connect a NOT gate at the output of OR gate, then it becomes NOR gate. If we are connecting a NOT gate at the output of OR gate, then it becomes a NOR gate. You can see the symbol of NOR gate. So at the symbol of OR gate, we are putting one bubble. So what bubble indicates? That O or symbol is bubble. That bubble indicates a NOT gate. A bubble is the symbol of NOT gate. A bubble is the symbol of NOT gate. So again, as the output, we have invert of OR gate. For OR gate, we have 0 0 0. All others input are 1. If for OR gate, again I am repeating, for the OR gate, we have 0 0 0, 0 1 1, 1 0 1, and 1 1 1 for OR gate. So here we have reverse process. For NOR gate, we have only 0 0 1. We have 0 0 1, otherwise 0 1 0, 1 0 0, 1 1 0. Now what is the condition for NOR gate? If any one input of the NOR gate, so sorry, for OR gate, what is the possibilities of OR gate? If any one input of the OR gate will high, then and then output will be high. But for NOR gate, what is the procedure? If any one input of a NOR gate is high, then our output will be low. If any one input of the NOR gate is high, then our output will be low. When our output will be high, when all the inputs of the NOR gate is zero. So again, it is the reverse thing. You can implement a NOR gate by using RTL also, which is resistor transistor logic, or you can implement by using NAND or diodes also. So this is the circuit for the NOR gate, which is constructed for the by the RTL logic, which is resistor transistor logic. Now this is somewhat a special gate, which is known as the exclusive OR gate. So when the output of the exclusive OR gate will be 1. So as a truth table, we have, if all the inputs are same, if all the inputs are same for the exclusive OR gate, then and then output will be 0. Then our output will be 0. If all the inputs are same, so we have either only two possibilities. Either it will be 0 0 or it will be 1 1. So all the inputs of the OR gate is same, then output will be low, or you can say 0. So truth table is 0 0 0, 0 1 1, 1 0 1, and 1 1 0. And you can see the symbol of exclusive OR gate, and also you can see uh, the equation of OR gate, which is y in the circle there is a plus b, or you can simplify the equation. My equation of exclusive OR gate is a bar b plus a b bar, a bar b plus a b bar. So this is the symbol of the exclusive OR gate, and the equation of exclusive OR gate is a b bar plus a bar b, or you can say a bar b plus a b bar. So the output is 1 only. We have the difference in the input, then and then output will be high. So 0 1 1 and 1 0 1, otherwise it is 0. This is a thing, or again it is a register transistor logic. So we have to combine AND gate, an NAND gate, and an OR gate to make a exclusive OR gate. Okay, so this is the transistor logic. The next one is exclusive NOR gate. Again, exclusive NOR gate. What is exclusive NOR gate? It is exclusive OR gate followed with a NOT gate. So again, the symbol of exclusive OR and exclusive NOR is nearly same. What is the difference between that? The output of the exclusive OR gate, we are connecting a NOT gate with the output of exclusive OR gate. So it is shown by a bubble. And now, what is the equation of exclusive NOR gate? It is AB plus AB bar. AB plus AB bar. So it is the reverse compared to the exclusive OR gate. When the output of exclusive OR gate is 1, when we have both the input different. So when the output of exclusive NOR gate will be 1, when we have all the inputs at the same state. If we have all the input as the same state, then our output will be 1. So if my A and B is 0 0, so both are in the same state. Either it is 0 0, or you can say both are is in 1 1. Then your output will be 1. If both the output is in another different state like 0 1 and 1 0, then our output will be 0. So this is the truth table, and again this is the circuit of exclusive NOR gate. So these are the theories. Now we have some pre-test. Okay, what pre-test indicates you are understand the theory or not. That is your test. Okay, so So this is the pre-test you have to submit. So let's check for the pre-test. Okay. Now the first is question is electronic circuit that operates on one or more input signals. Let's operate one or more input signal to produce standard output. Then what is the answer? Either it is series circuit, or it is a parallel circuit, or it is a logic signals, or it is a logic gates. Okay, so give me the answer. Okay, so Theria gives the answer, Miloni, Nisita, Parthiv, Keyur. What about others? Okay, so all of your answer is either it is answer D or the answer is logic gate. Okay, so I am take that it is logic gate. Now my second question. A gate gives the output as a 1 only if all the input signals are 1. So which is that gate which gives the output 1 only if all the input signals are 1? Okay. So Kayuri, Dirga, Mihir, Miloni. So the AND gate. Okay. So AND gate is the gate which gives the output 1 only if it's all the input signals are 1. Okay, very good. So the Boolean expression of an OR gate. So what is the Boolean expression? Or you can see the equation of OR gate. Okay, Miloni gives the answer. Parthiv, Nishita, Keyur. Very good. Its answer is C, A plus B. The next, the gate which is used to reverse the output. Dhairya. Dhairya.
Yeah, it is the area.
Sorry, Dhairya. Okay, so again the answer of Parthiv, Keyur, Disha, Dhairya, Kisan, Nishita is same that it is a NOT gate. So the gate which is used to reverse the output obtained is a NOT gate. Now the last one. Which of the following gate will give a zero? Will give a zero when both of its inputs are one. Which of the following gate will give a zero when both the inputs of is one? So when the both the input is one, the output will be zero. Okay, NAND gate. But same is we have exclusive OR gate also. Okay, you all are right, but there is some mistake in the quiz. Okay, if both the inputs are 1, the output will be 0. So we have two possibilities. All of you are right that NAND gets gives the output 0 when all the input is 1. Both the inputs are 1. And you can also remember what is the truth table of exclusive OR. The truth table of exclusive OR is 000, 011, 101, and again 110. So here there is some mistake. Now the correct answer is NAND, but here they have to write exclusive NOR instead of exclusive OR. They have to write here exclusive NOR instead of exclusive OR. Okay, so I'm submitting the quiz. Okay, so congratulations all. You are getting 5 out of 5. All the answers are correct. So next, we are already covered the pre-test. Then move forward to the procedure. So this is the procedure. Okay. particularly. But before read that, we are going moving to the simulation only. Then I will teach you how we have to connect. So we are performing the simulation of all the logic gates, which is AND gate, OR gate, NOT, NAND, NOR, exclusive and exclusive NOR. So first we are going to the AND gate. So what that means, see, here we have three switches. Here the switch will be in zero state right now. If you have to on the switch, once you are performing by yourself, you have to double click on that. Okay, so what it says, connect the battery first. So first we have to connect the battery. So go to the battery symbol and double click on that. So it is written like that, it is connected. But power is not going to the transistor 1 and transistor 2 because my switch 1 is off. Now first we have to connect the switch 1, or we have to on the switch 1. So I am double clicking on that. So see, you can see the change in color. If you close the switch, the wire will be red, and if you on the switch, your wire will be red, and if you on the switch, your wire will be green. So you can easily visualize that. Now when my bulb will be on, so bulb is our output, you can say. So this is the experiment of the AND gate. So these are the two inputs, switch 2 and switch 3. So now switch 2 and switch 3 both are 0. And as my switch 2 and switch 3 is 0, so my input is 0, 0. And we have to verify the truth table, okay, of AND gate. So 0, 0, 0. That's why bulb is 0. That's why bulb is not on. So suppose now my input is 0, 1. So my switch 2 remain as it is. I am on the switch 3. So now see, so my input is 0, 1. But again, bulb is not on. What that means? 0, 1 is again 0. Now instead of 0, 1, now I am doing 1, 0. So on the switch 2. So my input is 1, 0. So again at a 1, 0, my bulb is not on. What that means? 1, 0, 0. Now the last possibility is 1, 1. So I'm switch on both the switches, switch 2 and switch 3. Now you easily see the lamp is on. So this is the truth table of the AND gate which we are verified. Again I am repeating, if both are 0, then 0, 0, 0, 0, 1, 0, 1, 0, 0, but 1, 1, it is 1. So this is a simple thing you can do by yourself also in a virtual lab. It is very much useful. Okay, so this is the simulator one. Again, if someone doesn't know how to work, so again there is given the instruction how we have to perform. So this is the instruction. First we have to connect the battery. So how we can connect the battery? We have to double click on the battery. So it will be connected. Then what we have to do? We have to press the switch 1. So if we are press the switch 1, then battery is connected to the circuit. Before it will be disconnected from the circuit. Then what we have to do? Press switch 2 as our input and switch 3 as input B. And we have to verify the truth table of the AND gate. And the bulb is in off state, is like a off bulb, and the bulb is the on state, it is a yellow symbol. So instruction is also given here. If someone doesn't know how to work, it is very easy tool, a virtual lab. So we have another simulator also. So we have to check or verify uh, a truth table also. So here we have to write, suppose my input is 0. You have to verify by yourself. My both the input is 0. And suppose I am writing 0, 0, 1. So either it is right or not. And you have to check it. So click on a check. So in a truth table, see below what it says. This is my serial number. My input 00, and what I'm saying, my input output is 1. So what remark says that you are incorrect. You are incorrect. So by mistake, you are if you are putting wrong output, then it will be gives you the remark. Then your truth table is incorrect. You can reset that. Now again, suppose my input is 0, both the input is 0, and my output is also 0, and you have to check my input A is 0, B is 1, and output is 0. Again, you click on check, it gives you the next thing that you are right. If my A is 1, my B is 0, and again you can check, and 1 0 is also 0, and last one, if you are click both are 1 and my output are 1, and you can click on a check, it gives you the output. So this is the truth table. You can verify it by yourself also. So this is very easy tool known as the virtual lab. So this is for the AND gate. Now going to the another gate, which is OR gate. So this is the same thing. So we have two simulators. Here we have instruction. So first we have to connect a battery. So click on a battery, and now it written like that. It is connected. Now you can see if both the inputs are 0, then my lamp is off. So what that means is 0. So what that means, 0 0 0. But any one of the switch will be on, then my lamp will be on, because now my circuit is closed through that diode 1, and my diode 1 is forward bias, and it gives the supply to the bulb. Okay. So again, so my input is 1 0, so 1 0 1. Again, suppose I'm on the switch 2, so again it is on, so my switch 2 is on, so again it is on. Suppose we are start both the switch, and then also it gives you the output 1. Ah, मेरे वहाँ से next हजार ऊपर से phone करो तो. Sorry for the So this is the truth table. We can verify if both are 0, then and then output will be 0. Otherwise, if any one will be 1, so my truth table is 0 1 1, 1 0 1, and 1 1 1. So this is the implementation of OR gate by using two diodes. Same way we have simulator 2. Again, we have to verify the truth table. As you all know, so I'm writing for you only 0 0. My output is 0. So check it is correct. So 0 1. Also, my output is 1. For 1 1, my output is 1. And for 1 0, my output is 1. So this is the truth table of OR gate. Okay, it is very easy to understand how it will be work. Now going to the NOT gate. So again, NOT gate is a single transistor. So we have to connect a battery. Okay, so switch on the first switch. So if the switch is 1, this switch 2 is our input. Okay, switch 1 is for the supply only. Switch 2 is our input. See, so if my input is 0, see, my switch 2 is 0, then my output is 1. But suppose my switch 1, sorry, suppose my switch 2 is 1, then my output will be 0. So this is the reverse. When my input is 1, my output is 0, and when my input is 0, my output is 1. So this is the realization of a NOT gate by using a single transistor logic, or you can say resistor transistor logic, which is RTL. And simulator 2, again it is the same. If your input is 0, then your output is 1, and if your output is 1, if your input is 1, your output is 0. So this is the thing. Okay. So this is the realization of NOT gate. Now going to the NAND gate. Again, NAND gate is made by the RTL logic, which is resistor transistor logic. But now there is a change in the circuit. Suppose first I will show you in the AND gate. Okay. You can easily visualize the output of the AND gate is connected with a Q2 after the Q2. And if you want to reverse the output, and if you want to make a NAND gate, just what you have to do, connect the output before Q1. All the other things are same. You can uh, see here. Nothing a change in that two circuit. Before that, we are connecting output after Q2, and for NAND gate, we are connecting output before Q1. So again, we have to realize the truth table. So my truth table is for NAND gate is 001, 011, 101, and 110. So we will check that. Okay, so see, this switch 2 and switch 3 are my inputs, So both are 0. Then also my output is 1. So what that means, 001. Again, switch on the anyone switch. So again, my input is 01. So 01, then also my input is, then also my output is 1. Then switch on the another switch. Then also my output is 1. But if you are taking both the switch on, which is switch 2 and switch 3, so my input is 1 1, then at that time my output will be 0. See, if both the inputs are 1, then my output is 0. Then my output is 0. So again, it is the realized by the resistor transistor logic, and you have to verify the truth table. Okay, so 001, so my output is 1. For 01, again my output is 1. For 10, again my output is 1. And for 11, suppose you are checking like that only, then it is incorrect. For 11, your output is 0. So this is the truth table of NAND gate. Sorry. Now we have to go into the NOR gate. So this is the circuit of NOR gate. By with diode logic also, but generally we are using a resistor transistor logic. Okay. So connect the battery. So now what is the truth table of NOR gate? You can say it is the reverse of OR gate. So what is the truth table of OR gate? 000. All the other states, all for all the other states, my output will be 1 for OR gate. 011, 101, and 111. So here we have reverse process. For 00, my output is 1. For all other states, 01, 10, and 11, my output will be 0. So just switch on the switch 1, your output will be 1. See, because my inputs of the two transistors are 0. So 001. Now 010, 100, and for 1 1 again it is 0. Again it is 0. So this is the NOR gate. And same thing you can visualize via truth table 0 0 1 0 1 0 1 1 0 and 1 0 0. So this is the truth table. Now going to the another gate which is exclusive OR gate. So this is somewhat difficult figure. So instead of battery we have now power switch. Instead of battery now we have the power switch. If you want to switch on that, you have to click on that, then and then it will be on. Okay, so you can read instructions also. Provide the power to the circuit. So we are not giving a connect a battery, we are giving a power switch. So we are pressing the power switch and press switch 1 for input N, switch 2 for input B. So we have two switches, switch 1 and switch 2, and here we are giving a 5 volt to the transistors. Okay, so these are the instruction. Which gate we are making? We are making an exclusive OR gate. What is the truth table of exclusive OR gate? 0 0 0 and 1 1 0. If both the inputs of the exclusive OR gate are in same position or same state, then it will be 0. Okay, so 0 0 0 and 1 1 0. So here my switch 1 and switch 2 both are 0. That's why my output is 0. If I give the input to the any one switch, suppose switch 1, then my output will be 1. So for 1 0 it is 1 and for 0 1 it is 1. But if you switch on both the supply, then my output will be 0. So this is the truth table of exclusive OR gate. You can easily visualize where the current will be flow. Okay, where the current will be flow. So this is the circuit of the exclusive OR gate. You can also use the simulator. So 0 0 it is 0 for same input 1 1 again it is 0. When it will be 1 for 0 1 it is 1 and for 1 0 it is 1. The last one which is exclusive NOR gate. So again this is the circuit of exclusive NOR gate. It gives you the value of all the resistors which is R1 2 5 6 7 8 11 12, which we have to use the 10 kilo ohm resistor, and R3 R4 R9 R10 and I13 we have to use the 5 kilo ohm resistor. So we have to use accurate resistor, then it will gives you the correct answer, then and then it will gives you the correct answer. So again, now what is the truth table of exclusive NOR gate? It is the reverse of exclusive OR gate. So which is a 0 0 1 and 1 1 1. Otherwise 0 1 it is 0 and 1 0 it is 0. So it is the reverse of exclusive OR gate. It is the reverse of exclusive OR gate. So what we have to do? Simply First, we have to give the power to the supply. So click on the power. So my power is given. So now you can see as my both the inputs are 0, then also my output is 1. So for 0 0 it is 1, for 1 0 it is 0, for 1 1 again it is 1, and for 0 1 it is 0. When both the inputs of the circuit of the gate is same, then and then it gives you the output. So 0 0 1, again 0 1 0, 1 0 0, and 1 1 1. So this is the truth table of exclusive NOR gate. So it is very easy to perform an experiment in a virtual lab. Okay, so we are performing the simulation of all the gates. Now again, there is a test, which is a post test. So now please give me the answer in a chat session. So we have to go into the post test. Now the first one is the expression of an exclusive OR gate is, so which is the expression of exclusive OR gate? Either it is A bar B plus AB bar. The second answer is 3 bit. The C is A plus A into B. And third one is A bar plus B bar. So what is the correct answer? Okay, K gives the answer. What about others? Parthiv, Kisan, Nishita, Dirga, Sanna. Okay. So the answer is A. Okay, so the answer is A. The expression of an exclusive OR gate is A bar B plus AB bar, which is right. Now the second one. When the logic gates are connected to form a gating or logic network, it is called as a which logic circuit? So option is a combinational logic circuit. The second one is sequential logic circuit. The third one is systematic logic circuit. Or the fourth one is hardwired logic circuit. So what is the answer? Either it is combinational logic circuit. Okay, so Disha, Parthiv, Sanjana gives the answer. Miloni, okay. So the answer is combinational logic circuit. So we are using a logic gates to make a different types of circuit. You can say a half header, a full header, subtractors, multiplexer, demultiplexer, and that are the circuit known as the combinational circuits. That are the circuits of the combinational circuit. The third one, the NOR gate is OR gate followed by which gate? The NOR gate is a OR gate followed by AND gate, followed by NAND gate, followed by NOT gate, or none of the above. Okay, so Parthiv, KU, Disha, Miloni, Nistha gives the answer, which is a NOT gate. Okay, so all of you are right. The next thing is the NAND gate is an AND gate followed by again it is not. Okay, very good. The last one, in a Boolean algebra, in a Boolean algebra, the bar signal indicates which operation? OR operation, AND operation, not operation or none of the above. Okay, so again the answer is not. So Nishita, Parthiv, Keyur, Disa Miloni gives the answer, which is a not operation. Then you can check either your answer will be right or not. You can submit the quiz, so it gives you the answer that you are getting 5 out of 5. So what that means, our answer is right. All the answers is right. And then we have to use some of the references. So in references, you have the books which we you can use, uh, and you have some sites or the links which you can use for the uh, that logic gates or truth table for the logic gates. Okay, so you can also visit that how it will be work, what is the function of basic gates and function, how the register transistor logic, the digital logic gates, again you can check, and the combination and of multiple transistor logic gates without magnetic voltage drop, that you can check by yourself. So this is the experiment number one. This is the experiment number one in for particularly we are performing in a virtual lab. Now, how you have to submit that? So I have one prepare a Word file and I will upload it in your portal. You can take the printout of that or you can write that in your book. It's your choice. It's not compulsory for either you can take a printout or you can write in your book. And the same link which we are performing now, I'm giving that virtual lab online, which is by the IIT Bombay. Or you do not have to require need. Just go on Google and click that. Okay. Just you have to go on Google and write down the digital electronics virtual lab of digital electronics by IIT Bombay. You get the link. Okay. So this is our experiment number one, which is configure diodes and transistor as a logic gates and digital ICs for verification of truth table. So this is the mode of experiment. Generally, the mode will be online and offline both, but as we have to study as online, so the mode is online only. Otherwise, same thing. If you are come to the college, we are performing by using a resistor and transistor, and we are getting the same output or same truth table. We can verify it by using RTL, TTL, and diode resistor logic. You can use one software simulation software also, which is multi sim. Okay, which is multi sim. So in multi sim also we can design the same thing, but it is not compulsory. Now what you have to do, see, I am giving you some gap. So you have to draw a symbolic diagram of all logic gates. So simply you have to draw a symbols of all the logic gates, like we have in theory. So this is the symbol. This is the symbol of AND gate. Same way you have to draw the symbol of all the gates, not this circuit. Okay. You have to just draw the symbols. So here you have to draw the symbols of all the logic gates. So you have to draw the symbol of AND gate, OR gate, NOT, NAND, NOR, exclusive OR, and exclusive NOR. So for that you have a space. Next, you have to draw a pin diagram of IC. See how we have a gate. So for gate, we have one 14 pin IC. As I'm giving you a IC here, it is the IC of XNOR gate, which is 74236. So all the logic gates are come in the form of ICs which having 14 pins. So you have to draw the symbols of that IC like here I am drawing. Simply, just what you have to do, just you have to Google it. Okay. So which IC we have for a NOT gate which is 7404. So simply you write NOT gate IC. Click on that, go to the image. So this is the IC of NOT gate which is 7404. So in each and every IC except NOT gate, we have four gates inside. We have four gates inside because except NOT gate, we have three pin required for one gate. We require three pin, two pin as an input and third pin as output. But in NOT gate, we have only one input and one output. So we how many pin we have? 14 pin. In 14 pin IC, we have one pin as a ground pin and another pin as a supply pin. So pin number 7 is my ground pin in each and every IC. In each and every IC, pin number 7 is my ground pin and pin number 14 is my VCC, and we have to give a 5-volt supply to the pin number 14. And we are giving the input to the one and take the output from the two. You can take input from the 3 and take the output from the 4. So in each and every IC, we have four gates for AND or not, for AND or NAND, NOR, exclusive OR and exclusive NOR. For NOT only, we have 6 gate inside the IC. Instead of NOT, if you are writing here, AND gate IC and click on any hole. Suppose click on that. So see, this is the IC. Again, we have 14 pin IC. Pin number 7 is ground and pin number 14 is VCC. Pin number 1 and 2 is my input pin. Pin number 3 is my output pin. Again, in single IC, we have 4 gates. In single IC, we have 4 gates. So pin number 4 and 5 again input and pin number 6 as output. Pin number 9 and 10 input and 8 is output and 12 and 13 input and 11 is output. So this is the symbol of the all the ICs. So you have to draw the symbol in the given space. Do not need to draw the buffer. Okay, so do not draw the buffer. Otherwise, you can again Google it and you can find the buffer pin, buffer IC. You have to draw the NOT, NAND, OR gate, AND gate, NAND gate, NOR gate, and exclusive OR gate as exclusive NOR I already given. So these are the IC name. The NOT gate IC name is 7404. OR gate IC name is 7432. AND gate IC name is 7408. NAND gate IC name is 7400. NOR gate IC name is 7402. And exclusive OR gate IC name is 7486. Now the next one is transistor as a logic gates. So you have to draw the figures of that RTL, DRL here, which we have. Okay, which we have here. So this is the figure of AND gate. You have to draw here at the space of AND gate. So you have to draw that transistor figure here. Same way you have to draw that figure of NOR gate, OR gate, NAND gate, and NOT gate. We do not have the space for the exclusive OR and exclusive NOR, but just we have to draw the figures of NOT, NAND, or NOR here. So 5 gates you have to draw here, that figures. Again, it is given in that virtual lab only. Then you have to write the procedure by your own language. Okay, online procedure is already given here, but it is too much lengthy. See, in procedure, what go to the procedure. So there's gives for each and every procedure. Okay, so it is not compulsory that you follow this only, and for each and every gate you have to write. Just write the procedure in your language for particular any one gate. For particular any one gate. So I'm giving you the space like this only. Okay. So small space is required. So write down the procedure by on your language in in a 4 or 5 line. It is not compulsory. Okay, and for particular only one gate, it is not no need to write down the procedure for each and every 7 gates. So that multi-sim process we do not use till now. Okay, so diode as a logic gate as a symbol I am already given here. How it will be work. Conclusion you have to write down by your language, and now there is some question answers. So you have to give me the question answers. So this is the question one. Okay, give me the answer in chat section. The output of AND gate with three inputs. So now we have three input AND gate. Okay, A, B, and C is high when we have four options. So what is the right option? A, B, C, or D? If we have three input AND gate and the output of AND gate is high only when all the inputs are one. So uh, Parthiv, Miloni, Nisita, Keyur, Dirga, Kishan gives the right answer that it is C. When my A is equal to 1, my B is equal to 1, and my C is equal to 1. What that means, if my all the inputs are high, if my all the inputs are high, then and then my output of the AND gate is high. Either it is a 3 input or it will be a 4 input. Now read the second question. If a signal passing through a gate is inhibited by sending a low into one of the its input and the output is high, the gate is and which gate we have? Okay, what that means, if a signal passing through a gate is inhibited by sending a low into one of its input. So what that means, it's one of the input is low, 0, so another will be high, and my output is high, then which gate it is? So Kev gives the answer, Parthiv gives the answer. So it is a OR gate. If any one input of my gate is low and another will be high, then my output will be 1. What about others? Only Kev and Parthiv gives the answer. Again, you can say for NAND gate also, if any one input will be 0, then you get the same answer. So again, there is a, you can say both the answer is right, because what is the truth table of OR gate? 0, 0, 0, but 0, 1, 1, 1, 0, 1, and 1, 1, 1. And what is the truth table of NAND gate? 001, 011, 101, but 110. So if a signal passing through a gate is inhibited by sending a low into one of the inputs, so suppose both the inputs are 1, okay, so for both the inputs are 1, the NAND gate will gives you the 0, but sending a low into one of its input, the one input of the NAND gate is 0. What that means, it gives you the output high only. So for NAND gate also it is right, and for NOR gate again it is a right. So both the things are right. Either the answer will be NOR, or sorry, or NAND gate, or the answer will be OR gate. When used with an IC, what does the term quad indicates? Quad indicates. Okay. What does the term quad indicates? Either it is 2 circuit, or it is 4 circuit, or it is 6 circuit, or it is 8 circuit. Okay, Parthiv, Keyur, Nisita, Dirga gives the right answer. Quad means it is 4, simply. Okay, either it is digital IC or not, or the quad means 4. So when we are using an IC, the quad in term indicates the 4 circuit. So answer is B. Now the next one, the output of an OR gate with 3 input A, B, C is low. So we have OR gate, 3 input OR gate. Okay, which inputs are A, B, C, and the output will be low. So what is the possibility of the input for that? Okay, Parthiv gives the answer. What is the possibility of OR gate gives you the low output? There is only one possibility, is that OR gate gives the low output, which is if all the inputs of the OR gate is low, then and then output will be low. So the answer is A only. So Parthiv, Keyur, and Dirka gives the answer. If my all the inputs A, B, and C, all the inputs A, B, and C are 0, then my output of the OR gate is 0. Otherwise, for any another combination or any another possibilities, my output of the OR gate is always 1. Okay. What is the possibility of the OR gate? 0. Output of the OR gate is 0. If all the input of the OR gate is 0, then and then my output of the OR gate is 0. Which of the following logical operation is represented by a plus sign in Boolean algebra? So Keyur, Nisita, Parthiv, Dirga, okay, gives the right answer, which is C, or operation. For inversion, we are using a bar signal. For AND operation, we are using the symbol of multiplication, or you can say a dot. For the next one, the output will be low for any case. The output will be low for any case when one or more inputs are 0. For which gate? Okay. Kevur gives the answer, Parthiv gives the answer. Again, I am repeating the question. What that means, what it says, if any, my output will be 0. In which condition? One or more inputs are 0. If my one or more inputs are 0, so in which condition my output will be 0? So for a OR gate, if my one input is 0, but my another input is 1, then my output will be not 0, it is 1. So OR gate is not that. NOT gate is only a single input gate, so we are not considering that. For AND gate, if any one input of my AND gate is 0, then my output is 0, because its equation is A dot B. So if A is equal to 0, so 0 multiplied with anything, it is 0 only. So my answer is 1. My answer is AND only. For NOR gate, what is the truth table of NOR gate? The truth table of NOR gate is 0 0 1, otherwise 1 0 0 0 1 0 and 0 0 0. So sorry, 1 1 0. But if both the input are 0, then it will be 1. So NOR gate is not there, not the right answer. So the right answer is AND gate only. So if any one input of the my gate is 0, then my output will be 0. So which gate it is? It is the AND gate. The next question is the format used to present the logic output for the various combination of logic inputs to a particular gate. It is known as the Boolean constant. It is known as the Boolean variable. It is known as the truth table, or you can say it is known as a input logic function. What it is? The format, which format we are using to present the logic output with a various combination of input. We have numbers of various combination of input, and we have output. So for 0 0 it is 0, 0 1 it is 1, 1 0 it is 1, and 1 1 it is 1. So format, which is format we are using? Only K will gives the answer. What about others? Okay, Parthiv, Dirga. Oh, which format we are using? It is known as the truth table. It is known as the truth table. It is the format which gives you the possibilities of output for a various combination of inputs. So this is the thing, is the format, and that format we are known as the truth table. So my answer, right answer is C, which is a truth table. So we are using a truth table which shows us the various combination of input and the output. Okay, now if we have three input AND gate, has 8 input possibilities. Okay, as we have three inputs, so how many possibilities we have? For numbers of input, we have 2 raised to n possibilities, as already I said. So for 3 input, my n is equal to 3, so 2 raised to 3, it gives 8. So if we have 3 input AND gate, so we have 8 different possibilities. So how many of those possibilities will result in high output? So in which, how many possibilities we are getting high output? Okay, only K will gives the answer. What about others? For my AND gate, we have 8 different input possibilities. So at how many possibilities we are getting high output? Okay, Parthiv, Kisan, Sanjana. Okay, so only we have one possibility. How many inputs we have? 3 inputs. So which are the possibilities? Just I am saying that it is 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0. So out of these 7, we have a one input is 0. So when the output of AND gate will be 1, when all the inputs are 1. So the last one is 1 1 1. So there is only one possibility is when the AND gate gives you the output 1. So there is only one possibility is when all the inputs of the AND gate is 1, then and then the output of the AND gate is 1. There is no another possibilities for AND gate gives you the output 1. Okay. So only one possibilities we have at which time we are getting the high output. Now the next one, the Boolean expression for the three input AND gate is, so which is the, okay, Kev, what is the Boolean expression for three input AND gate? Either it is AB, A into B, or it is A into B into C, or it is A plus B plus C, or you can say AB, A into B plus C. So Keyur, Parthiv, and Dirga only gives the answer. What about others? We have three input AND gates. Okay, we have three input AND gates. So what is the Boolean expression for that three input AND gate? Either it is A, either it is B, or it is C, or it is D. So Keyur, Parthiv, and Dirga gives the right answer that it is B. What is the Boolean expression for AND gate? A multiplication of each and every inputs. So how many inputs we have? Three. So we have to multiply each and every three inputs. So we have to multiply A, B, C. So the equation is A into B into C. So it is somewhat difficult and question because we are not drawing the pin diagram. Okay, what are the pin numbers of the output of the gate in 7432 IC? So generally the pin number is 3, 6, 10, and 30. The answer is A. Okay, if you see the 7432 IC, okay, we'll see. Okay, so suppose this is the pin diagram, you can say. So my mistake. So what is the a pin number which having a connect with output? So which pins are connected with output? So here we have three number pin. Okay, we have six number pin which is connected with output. We have eight number pin which is connected with output, and 11 number pin which is connected with high output. So 3, 6, 8, 11 is the answer. So 3, 6, 8, and 11 is the answer. So the answer is C. Or the answer is C. 3, 6, 8, and 11. The next question is, how many inputs? How many inputs? Okay, Kev directly gives the answer. How many inputs of four input AND gate? So we have one AND gate which having a four inputs. So how many inputs of the four input AND gate must be high in order to get output high? So any one of the input is high, then output will be high. If two inputs is high, then output will be high. If three inputs is high, then output will be high. And if all the four input is high, then my output will be high. What is the possibilities? For AND gate, again, what is AND gate? When the AND gate output will be high, when the AND gate output will be high, if all the inputs of the AND gate is high, then and then output of the AND gate is high. So the right answer is answer number D. If your all the four inputs is high, then and then your answer, your output will be high. Then and your output will be high. So answer is D. Only Kev gives the right answer. And the again it is the same thing. What is the Boolean expression for the three input AND gate? It's already covered in above. So it is the right answer is B. X is equal to A into B into C for the AND gate. Now the last one. Sorry. Now the output of exclusive OR gate. Okay, the output of exclusive OR gate is high if when the output of exclusive OR gate is high, if all the inputs are low, if all the inputs are high, if the inputs are unequal or none of the above. Output of exclusive OR gate. Okay, Parthiv gives the right answer, Keru gives the right answer. When all the inputs are unequal, then and then the output of the exclusive OR gate is high. Suppose what is the truth table of exclusive OR? 0 0 0 and 1 1 0. So both our inputs are low and both the inputs are high, then it is 0. But when it is 0 1, then it is 1, and for it is 1 0, it is 1. So when both the inputs are unequal, then and this is the last question. How many input combination we have in a truth table for a 6 input AND gate? Okay, KO gives the answer, Parthiv gives the answer, Theria gives the answer. It's 64. It's 64. Why? Again, I'm saying what is the possibilities of the input? Then that we have 2 raised to n inputs. When n indicates the sorry, we have 2 raised to n combination when n is the number of input. So we have 6 inputs, so n is equal to 6. So 2 raised to 6, it is 64. So the right answer is 64. So this is the experiment number 1. That word file I will share in your WhatsApp group. I will also upload this in our Marwadi portal, and I will also share it with your Telegram group. So you can download from there, take a printout, and complete the manual. I don't know where when the college will be start, but once it is start before the semester end, then you have to submit this experiment. Okay, then you have to submit this experiment. Otherwise, you complete it and send it. Take a photograph, do the PDF, and send me in my mail, or you can send me in a WhatsApp personally. Okay, so this is the experiment number 1. Now, anyone having any doubt, you can unmute yourself and ask me a question. Yes, yes, I already said you can edit a Word file. Okay, you can edit a Word file rather than writing in hard copy. Okay, okay. But the subject coordinator is the Sunil Lavadia sir. Uh, Let me first ask him. Okay, so afterwards I will let you know how do you have to submit that. Okay, so again we have 10 to 20 minutes if anyone having any doubt regarding a virtual lab, regarding the experiment. If anyone having any doubt, you can ask me a question. You can unmute yourself. Okay, so okay, so thank you. So please now you can write down your name. Also, okay, it's not necessary to write down your name. Please write down your last 2 or 3 digit for the attendance point of view. And from the next session, I required the answer from all of you. Just only few of you are gives the answer frequently. The like Parthiv and Keyur, and Dirga, Nishita, Miloni. These are gives only the answer. I require the answer from all of you. Okay, then I will understand you are aware. Okay, so if anyone is pending, please write down your last 3 digit for the attendance point of view. Only Dhairya, Parthiv, Keyur, Sanjana, Miloni, Kisan, Nisita, Kushal. What you have to ask, sir? They are lab representatives. What that means? Anyone can unmute themselves. What about others? I think some of you are putting your mobile aside and doing another things. Only okay. You are also genius. They all are genius. Why you are not a genius? It's not like that. It's the simple thing which you already studied in basic electronics. Okay, and the subject is it's not much difficult. The theory today we'll study today we were studied is not that much difficult that you didn't give the answer. We have 24 participants, and out of 24, only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 gives the attendance. What about others? If I'm closing the meeting right now, then they will send the message. Sir, please give the attendance. Okay, so Jai and Dipen gives the attendance. What about others? Please send the message to your phone. Send a message to your friend, then it will be gives the attendance. Otherwise, okay. So I'll wait for the 2 3 minutes, and afterwards I will close the meeting. So those who are remaining, they have to send me the message for the attendance. Those who are already give their attendance, they if they want to leave, they can leave. Okay, so those who are giving the attendance, if they want to leave, yes, Nisita, I know. It's not Nisita, it's Nisita. Okay.
Sir, it's Nishtha.
It is the number of Kisan, Mitul, Niyati, Kev Desai. They are not giving the attendance, or they will join at 11:20 or 30. Okay, so thank you everyone. Now I'm okay. Kev, we already given. Okay, so only that Jai, Kisan, and Niyati are remaining. Okay, okay. So almost all are giving the attendance. Okay, thank you everyone. So we will meet at 1 today for the lecture. So thank you everyone.